welcome to my online e-math classes. This is a topic of chapter 14 in CBSE 11th class MBE syllabus, and the chapter name was annuity, and now we are discussing 14.4, and this is a concept of that exercise. So look at that exercise, the concept. In the previous section, we have learned that amount means the future amount, okay, and the present value of regular payments. Regular payments means every term period they are doing deposits or payments at the end of that time period. But this is a case of annuity due. Look at this word, annuity due. It is very important to understand what is annuity and annuity due. Annuity due means, look at this diagram. In this diagram, you can understood that the total time period was, suppose, n years, or you can also take like n months starting from today. And a payment was done now. Now it was done, right? So that means at the starting position, you are doing a payment, not waiting for the end of the month. So it is a case of due case. Such cases are called due cases. So R is a payment doing now. So that means month ending was not okay. Zero payment, and you are doing this payment, R payment. So it will be invested up to n time periods, up to n months, for example. Up to n months, this payment was invested. Okay. So how much interest was, how much that amount at last you will receive by doing this payment now, today. So the amount, from compound interest, it will be invested amount R into 1 plus I whole power n. Next, for the next month, same starting date. For example, every month you are doing payments at first date. Okay, every month of first you are doing payments. For example, suppose you assume like that. That means then the next month, if you do the payment, then payment will be invested up to n minus 1 months. And again, for the next month, you are doing the payment at the first date, then it will be invested for the next n minus 2 months. And these are the amounts you will earn by investing that amount, that payment. Okay, it was continuously up to last, and remember, the nth payment was not needed. Up to n minus 1 months, you have to pay that payment, regular payment, or every month at first date. So that at the last, it will be invested for the 30 days only, right? So R of 1 plus I whole power 1 month, or 1 year, or 1 month, whatever it is. The last month you should not pay anything. That will be the last month after getting completing the 30 days of period, you will receive the total amount. Let's calculate the total amount. So last month, no need of payment, and you are starting payment from today. Okay. So that is what called, it's a case of annuity due. Understood? Now So adding all these values, amount A equal to, this is a future amount. So because after completing this entire payments, we will receive at last that amount. That amount will be, look at this, r into 1 plus I, here I wrote, and r into 1 plus I square, and every amount for individual investments, what we received at last. So there is all payments, all amounts are added together, and clearly it was a geometric progression. R is a common factor, you can take that out. So r into 1 plus I is a common factor. Then you have how many terms participated in this geometric progression? N terms is there, right? So 1 plus I whole power n, starting from 1 to n, so n terms complete. So this is r power n minus 1 by r minus 1. So using this formula, you will get A equal to r of 1 plus I into 1 plus I power n minus 1 divided by I. For using annuity table, we should use this minus 1. Just multiply this 1 plus I to these values. So r will be same. 1 plus I into 1 plus I power n, how much? 1 plus I whole power n plus 1. And minus 1 into 1 plus I, how much? So minus 1 into 1, minus 1, minus 1 into I, minus I, whole divided by I. Clear? So r will be same. 1 plus I whole power n plus 1 same, and minus 1 we will separate this I up to this term, and I by I, you know, I by I is minus 1. So remember this formula, this is a formula. So what we have to use for calculations, for due cases especially, this formula we will use. And A equal to R of, for annuity tables, we will use these values as S of n plus 1 bar whole divided by I minus 1. So, okay.